Good morning and welcome to my YouTube channel. I am Arthur Francis Diba. We've been dealing with organic chemistry all the while. We are done with alkanes, alkynes, and their reactions. This time around we're going to be going through the naming processes, although we're going to concentrate on functional groups, which are very, very important. How do we name compounds that have functional groups with them? So, in order to do that, I have to give us a table or a little explanation about the functional groups, how to identify them, and how to go about them. That's very paramount. So, we know too well that the alkanes have a single bond as a functional group. We have the alkenes have a double bond. We have the alkynes as the triple bond. We have many more. We have the carboxylic acid, the hydroxy group, and so on and so forth. So I'm going to look for them to bring them to our clarification today so that we can see what we're going to do with them. And the order of precedence is very important. If we have two functional groups, which one do you name? Which one do you give, pay more attention or focus to? Which one takes precedence over the other? Which one owns the compound? That is very important. So I'm going to give us just a little few of them. So let's see what it is. But then, what is a functional group? See, it's an atom or group of atoms that can cause a compound to exhibit a particular behavior. A functional group is an atom or group of atoms that can cause a compound to exhibit what? A peculiar behavior. Let's call it peculiar because, for example, if I have a functional group which is the hydroxyl, the OH attached to a compound, let's call it CH3 OH. This is methanol. Now, what makes this compound an alcohol is this OH. I can see how CH3 hydrogen. This is an alkane. This now give it a different reaction, and we can see how CH3 OOH. This is a carboxylic group, an alkanoid. So this being the functional group, makes the compound to exhibit what a peculiar or a particular behavior, or takes a behavioral pattern different from others. As such, you'll be able to call this a methanol from alcohol, an ethanoic acid from alkanoic acid, and this is an alkane, a single bonded compound. Let me give us a little of these functional groups. We know that alkanes are single bonded, so we're not going to talk much about that. Alkenes are double bonded. Okay, let me just put them out. Alkanes so these are the few functional groups we're going to deal with. Now, according to the order of precedence, which I'm supposed to have illustrated, but these are all functional groups. Now, how do you know when you're dealing with a compound and you have two of these functional groups in there, which one do you take or give precedence to? Which one do you take as a parental compound? That has to do with the molecular weight of the compound. How heavy is the molecular weight of that particular compound compared to another? For example, if I have OH in a group or in a chain, and I have a carboxylic group in a chain, I know too well that from here, this is 12, 16, 16, 32 plus this, 33 plus 12. That's far heavier than 16 plus 1, which is 17. So this take precedence. This take precedence over this. So this now becomes a substituent because this is heavier. And so on and so forth. That is the manner in which you're going to use to recognize them. So let me take certain questions so that we can go through them and see how we answer them in our naming process. So let's take question. We have dealt with the rules before, but we'll just go through them as in answering the questions directly to see how far we have mastered the rules. And the difference is there will be a little addition of the functional groups inclusive, because they weren't in the first place where we were dealing with the other ones. We only dealt with heteroatoms, which could be the nitro, hydrogen, and thereabout. But this time around, we could have carboxylic groups, we could have aldehyde, we could have ketones in there. So let's see what we do with that. So let's take questions and name them. All right, our first question we have. Okay, we are advancing further. So we are not going to be putting the hydrogens like we've been doing from the elementary aspect or the time we started, knowing too well that each carbon have the imaginary hydrogen surrounding it. And you know carbon is tetravalent, so you should take note of that, you don't forget that. So in this, like they have been giving us for the test, without the hydrogen we should master the art. So let's see how we name this. Remember we say in the course of naming the rules, that one of the rules is, first you identify your parent chain. The parent chain is often the longest chain. So if I look here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. No. 1, 2, 3, 4. No. So I go with this 1, 2, 3, 4, 5. The parent chain now is pentane. So that is number one. Number two, we have to consider which side are we going to start the naming process. Are we going to start from this side as number 1, carbon 2, or from this side? We have to check that by checking the number of locans. The one that have the lowest possible number of locans becomes what the direction in which we're going to begin. Let's take from here. This is, if I start from here, putting here 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Okay, from here, this is 2. I have a local in 2. I have another one in 3. 2 plus 3 give me 5. So the upper side give me 5. The downside is 1, 2. I have in 3 and in 4. 3 plus 4 is 7. This is 7. So which one is the lowest? This side is the lowest. So which means my naming must come from this direction, because I have the lowest possible what? Number of locans from the upper side. So this becomes my 1, 2, and so on. So I get rid of this other one. So you don't forget the rule, so that you will not be lost. Okay, having said that, now if this is the side I'm going to start with or deal with, in carbon 2 I have a methyl. This is a methyl. In carbon 3 I have another methyl. So now I have 2 methyls. In chemistry, when we have 2 methyls, we call them di. If we have 3, in short, 2 is called di, 3 is tri, tetra, and so on, penta, hexagon, we go on. So I have in 2 and 3, I have 2 methyls. So this becomes 2, 3 dimethyls. Alright? Because there are 2 methyls. 2, 3 dimethyl pentane. So now we can put it down by saying 2, 3 dimethyl pentane. So this is our first structure. We're going to get more. Alright, let's take the second one. Okay, from here we have to identify our parent chain. If we take here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is this. So 8 is octane. So we leave it at that. Now let us look at the substituent. 1, 2, 3. In 3 I have a substituent. 4 I have. 5 I have. So on. And they are all methyls. So now, which side do I begin with? 1, 2, in 3 I have a methyl. 1, 2, 3, in 4 I have a methyl. So 3, in 4 another one, so obviously it is this side I should come from. So, if I have here as 1, 2, 3, 4, 5, 6, 7, 8. I have an octane as a parent chain. Now, in 3, let's take the substituent. In 3 I have a methyl. In 4, I have another methyl. In 5, I have another methyl. Okay, so this becomes 3, 4, 5. There are 3 methyls that become tri. Since there are 3, so I call it trimethyl octane. So this becomes the name of the compound. We are just asked to get the names, and that's what we're doing right now. So let's take another one. Okay, if this is correct, let's look at it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 5. Now, in 2 directions, we are having 7. From this direction and from this direction. We are looking at which one should become our parent chain. Am I right? Now, they say we should look at the longest chain. And now, here I have 7, here I have 7. I cannot define that this one is longer than this. So, the both sides give us 7. The next thing we consider, since from both ends we are having 7, we look at the one that contains more substituent. That contains what? More substituent. If I go this way, I have just one substituent, which is in carbon free, and that is 1, 2. 1, 1 dimethyl ethyl before I can attach it to this. But if I come from this direction, I have 2 substituents here, I have another substituent here, that's 3. So it becomes very important that this should be considered as the parent chain because it contains more substituent, unlike this other one that contains just 1. So here I will now have 1, 2, 3, 4, 5, 6, and 7. Now, in carbon 2, I have 2 methyls. And in carbon 3, I have an ethyl. So we have methyl and ethyl. Of course, we've been told that we should always consider the alphabetical order. Which one comes before which? E comes before N. So I will consider the ethyl before the methyl. So I will say, in that case, let me clean this. In carbon 3, there is an ethyl. So I say 3 ethyl, 2 dimethyl, is 7 heptane. So the compound becomes 3 ethyl, 2 because in carbon 2 I have 2 methyl. So that becomes 2 dimethyl heptane. So we continue to take more. Let's move further. Okay. In this one, if we count from here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, we are considering this 8 or this 8. Good. Now, let's consider if we take this 8, we have just one substituent. All of this becomes a substituent. But if we consider maybe this 8, we have 1 and 2 substituents. So our interest will come down to this side. So as such, I have my 1, 2, 3, 4, 5, 6, 7, and 8. Now, in carbon 2, I have a methyl. In carbon 4, I have a propyl. That's 3. Propyl. So, N and P, which one comes first alphabetically? N. So this will go first. So we have 2 methyl, 4 propyl, octane. 2-methyl 4-propyl octane. The parent chain is octane. So by so doing, you continue to name on and on and on and on. Let's go. Okay. Let's look at this. Now we have 1, 2, 3, 4, 5, 6, 7 as our parent chain, yes. Now we have methyls all over. We have one methyl here, another one, another one. Now we have to consider the locants. Which one becomes first? If I 1, 2 here, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So from here, let's take the lowest possible number, which will become our locant. We have 2 plus 3 plus 6. Here we have 2 plus 5 plus 6. 9, 10, 11. Here we have 11. 11, 12, 13. Here we have 13. So we take the lowest one to be from this direction. So that becomes our parent chain and the direction in which we're going to start with. So if that is where we're going to start from, so we have a substituent in 2, 3, and 6. So I will have my 2, 3, 6. There are 3 methyls, so that becomes tri. 2, 3, 6 trimethyl heptane. Alright, that is it. Let's take more. Now we have to consider the locant. Which direction do we start from? Here we have ethyl, ethyl, methyl, chlorine. That's chloro. So obviously this is where we're going to start because everything actually falls back to this side. So if that is the case, this becomes 1, 2, 3, 4, 5, 6, 7, and 8. Now in carbon, now we have ethyl, which is E. We have methyl, N. We have chloro, which is C. Alphabetically, C comes before E, before N. So we start with the C, which is 2-chloro. We come to E, which is in 3,5. 3,5 diethyl we come back here to 4. 4-methyl octane. So 2-chloro, 3,5-diethyl, 4-methyl octane. Because our parent, the name of the compound. So quickly, let's move. All right. From here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the longest. So if that is the longest, from 1, 2, 3, 4, 5 from here. 1, 2, 3, 4, 5 from both directions. So we can just call it 1, 2, 3, 4, 5, 6, 7, 8, 9. That's no name. So to name this is a no-name, but we start from 5. We have to know what this is. So here, this is a substituent. All of this is a substituent, which contains some other substituent in it. So from the substituent, I have 1, 2, 3. Okay, in this sense, 1, 2, 3 is the parent chain of the substituent, which is a propyl. So, it's a propyl, but in the propyl we have 1, 2, in carbon 2 we have 2 methyl. So this becomes 2,2-dimethyl propyl before we come out. So now let's start. In 5, we say 5, open brackets, 2, 2, dimethyl, okay, in propyl, 2,2-dimethyl propyl. I close my brackets. Noname. Now 1, 2 in this propyl, so I have in 2,2-dimethyl propyl noname, because in 5 that is where all of this is happening. So I started with the 5, which is here. In 5 I have 2,2-dimethyl propyl noname. So that's that. Let's take another one. Now we say when there are double bonds, either 1 or 2 double bonds, when considering your parent chain, you must ensure the double bonds are all inclusive. They are all involved inside in your parent chain. This 1, 2, 3, 4, 5, 6, 7, 8 is longer than 1, 2, 3, 4, 5, 6. But we don't consider this as a parent chain because it has only just one double bond in it. So we have to consider this to contain as many double bonds as possible. So this becomes my parent chain, 1 to 5. Now in carbon 1, the double bond here is 1, here is in 2. So I start from here, 1, 2, 3, 4, 5, 6. In carbon 3, I have 1, 2, 3, 4. That is called a butyl. Okay. Now I have 3 butyl, 1, 4, hexadiene. Now this is hexane, perhaps like a parent chain of 6. Hexane, but I have 2 double bonds, so it becomes hexa. Now hexadiene means I'm telling you that there are 2 double bonds in between. So this becomes diene of 1 and 4. So this is for 4. So 3 butyl, 1, 4 hexadiene. This is diene for double bond. In. Di means there are 2. Or, okay, I think we are good with that one. No need to get an alternative. Hexa 1,4-diene, if you want to call it, but this is more preferable. So that is the name of this compound. Let us move further. Now, let's look at the one that contains a functional group. So if you look here, you see that we have a double bond, which is an alkene. We have an aldehyde, an alkanal functional group. This is an R. Okay, if we want to name it, this takes precedence over this. So I can begin by looking at 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. 2-methyl. 1, 2, 3. Hexane, or 3 hexane, 1 R. 3, no, sorry, this is 2. 2-methyl, 3-hexene. I do not need to put the completion. If I put in hexene complete, that's over. No, I can't add any other thing hexene. 1R. This is the functional group, which is an R canal. So it must end with that R. Okay? So if this were to be here, I can call it hexenal because it is in position 1. But it is in position 3. So 3-hexene, 1R. So this is it. Now, the reason why I brought the table of the functional group earlier, but you'll be able to know which one takes precedence over the other. That of alkanal is more superior to the alkene. So this takes the name of the compound, like we see in any other one to come. Let's take any other one. So, although by mere looking, this takes precedence over this. So the name of the compound must certainly end with this. Although they are all heteroatoms. So now, we look at this. 1, 2, 3, 4, 5, 6. This takes precedence over this. So this because we name this first, which is 1 bromo. One, two, three. 3 nitro hexane. Hexane. 1, 2, 3, 4, 5, 6. So that is that about that guy. Okay, let's take probably another one. Now, if you look here, you see that we have a triple bond and a keto group here, which is the alkanone. So this is more superior to this. So everything will come from here. So if I come from here, I have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So this is 5 octane, because this is 8. 5 octane 3, 1. Because this is, it ends with own, alkanone. For example, alkanones. This is it. So if I remove it, let's call it alkanone. So this is the one for the keto groups, which must take precedence. So the name of this, without this, would have been what? 3. This is the keto group for the octanone. 3 octanone, because it is in carbon 3, we have the double bond. But now we have an oxygen group there. But now we have a triple bond here, which is normally octane without this. So we call it 5 octane 3, 1 from the alkanone family. The alkanones will take precedence because it's more superior. So I have 5 octane 3, 1. That is it. Now, the essence of the functional group illustration is for us to know which one takes precedence over another. So, okay, let's see. They are giving us some structures to name. Let's just take 2 or thereabout. Take 2. Now, of course, this takes precedence over this, so I start from here. 1, 2, 3, 4, 5, 6. Now, in carbon 4, I have a hydroxyl group, and in carbon 2, I have a keto group. So, this becomes 4 hydroxyl hydroxy 2 hexanone. 2 hexanone. Or hexan 2O, if you want that way. 4-hydroxy hexan 2O. We call it 2-1 if you want to call it that way. 4-hydroxy hexan 2O. If you prefer that, you can use that. Let's take one more. Okay, let's call this the last one for today. So this, we have an amino group. This is a carboxylic group, so this takes precedence over this. So let's start from here. Call it 1, 2, 3, 4, 5. So 3 amino pentanoic acid. So if I remove this is a pentanoic acid. But now I have a substituent in carbon 3. So that becomes 3 amino pentanoic acid. So we will stop here for the day. In our next class, we should be taking alcohols and the various classes of alcohols, the primary, secondary, tertiary, and quaternary, which, like we discussed earlier on when we started the introduction of the organic chemistry, the classes of carbon, which is the primary, secondary, tertiary, and quaternary. With that format, that knowledge, we'll be able to understand alcohols to that. And another classification of that has to do with either di or tri in terms of the OH group attached to them. Okay, the polyhydric, dihydric, trihydric, and so on. And after that, then we can look into maybe carboxylic acid and so little more other ones, so that we'll be able to cover the basic things that are required. The formal knowledge required in terms of naming all organic compounds and the certain reactions they undergo that will become more solid. So in terms of any questions or anything you don't understand, don't hesitate to send your questions or whatever to the comment section. I will look into it and get back to you. Thank you and have a